Okay, this is a revision assignment set 1. First question, which apparatus? So you have to write down all the working, all the things that I write down, okay, as you go through this video. Which apparatus is most suitable for measuring approximately 15 cm3 of liquid ethanol? Now, beaker, it is not for measuring. Okay, it is not for measuring a liquid. Okay, it is actually for estimating. Okay, burette, yes, it can be used to measure the volume of a liquid, but then burette, usually the measurement or the reading usually is like 1 decimal point or 2 decimal point, for example. Okay, 15.1 or 15.15. That's for burette. Now for measuring cylinder, usually the reading would be a whole number. Okay, usually it is whole number. So for example, 15 cm3 or maybe 11 cm3. That's for measuring cylinder. And then for pipette, either 25.0 cm3 or 20.0 cm3. Only can be these two, one of these two. Okay, so 15 cm3, so it's very obvious that the answer is measuring cylinder. Alright, so make sure you write down all this thing on your paper. Okay, sample of nitrogen dioxide gas. Nitrogen dioxide, what is the chemical formula? NO2. Now you need to know that nitrogen dioxide is an acidic gas. Okay, it is an acidic gas. Some other acidic gas would be like sulfur dioxide, carbon dioxide, etc. Now it is so it is a gas. It is cooled. It is a gas at room temperature and pressure. It is cooled, and the temperature is measured every minute. The following graph is obtained. So which means that this one must be the gas state. Okay, so this horizontal would be when the state change occurs. So this one would be gas and liquid. As you cool the gas, it will become liquid, and then this one would be liquid. So which row best describes the arrangement and movement of the particles in the region YZ? So basically this region, liquid. So if you look closely, if you look at this moving at high speed, this one must be gas, high speed. Fixed position must be solid. The movement, fixed position. Vibrate about their fixed position. This one is vibrate about fixed position, while some move freely. So this one would be solid and liquid. Okay, because it's fixed position, so this will be solid and liquid. Now if you look at A, arrangement of particles closely packed in disorderly arrangement, move freely. Now actually for liquid, the arrangement of particles would be less closely packed than solid. So this is close enough. Move freely over each other. Liquid is actually slide over each other. So it is, close enough. So the best answer is actually A. Okay, number 3. Which gas has the lowest rate of diffusion? Now you know that diffusion depends on 2 factors. The first one is the MR, relative molecular mass, and the other one is the temperature. Okay, let's look at MR and temperature. MR, the higher the MR, the larger the MR, the slower would be the rate of diffusion. Now for temperature would be the higher the temperature, the faster would be the rate of diffusion. So the slowest rate of diffusion, meaning that I want a very large MR and I want a very low temperature. So low temperature, so it's either A or C. So for A and C, we compare the MR. Now fluorine, what is the what is the chemical formula for fluorine first? It is F2. Now remember all the group 7 elements, all the halogens, they exist as diatomic at room temperature and pressure, meaning that F2Cl2Br2. So F2, and what would be the MR? So the MR of F2 would be 19 plus 19, okay, because the mass number is 19, so 19 plus 19, 38. And then for hydrogen, you know that the MR for hydrogen, H2, the MR will be 1 plus 1, which is 2. So I want a higher MR, a larger MR, and a lower temperature. So the answer would be A. Number 4. In order to prepare and collect dry sulfur dioxide gas. So just now we look at sulfur dioxide gas. It is an acidic gas. It is an acidic gas. What modification should be made to the experimental setup shown? Now, see, sulfur dioxide will be produced here. Okay, then after that, it's bubbled into this potassium hydroxide. What is potassium hydroxide? Potassium hydroxide is actually an alkali. And then you have acidic gas bubble into alkali. There will be neutralization reaction. Neutralization reaction meaning that salt and water will be formed. So your SO2 will be gone, which means that you cannot afford to bubble sulfur dioxide into potassium hydroxide. So you got to remove flask X completely. Okay, what is this concentrated sulfuric acid? Now this one is actually a drying agent, meaning that it will remove the moisture in the air, in the sulfur dioxide gas. So this one is a drying agent. What is this upward delivery? Upward delivery is to collect gas. It is to collect gas. So this is in chapter 2. To collect gas which is less dense than air. Alright, that's number 4. Number 5, what is the effect of chlorine gas on moist litmus paper? So that means the testing of a chlorine gas. So this one is under salt chapter 12. So this is under salt chapter, okay, which is chapter 12. How to test for chlorine gas? It will turn a moist blue litmus paper into red and then bleach. That means become white color. Okay, it become the blue litmus paper become red and then after that bleach, meaning that become white color. Okay, that's number 5. Okay, number 6. Okay, number 6, the diagram shows how precipitate Y can be obtained from solid X. Okay, you heat solid X, white solid X, and then you get a colorless gas and a white solid. See, when you have a compound, you heat the compound, become another compound, and then a gas. So this one is a decomposition. Okay, and in our syllabus, the most common decomposition reaction would be the this is a thermal decomposition. The most common one would be the thermal decomposition of carbonate. Okay, so this reaction, thermal decomposition of metal carbonate. So for example, calcium carbonate, you heat it, it become calcium oxide. Okay, so this is a carbonate, this is an oxide, and then plus carbon dioxide. Alright, so over here you can see colorless gas. So this colorless gas must be carbon dioxide, and then after that colorless gas combined with this colorless solution, it becomes a white precipitate. So this one sounds like it's a test for carbon dioxide. So carbon dioxide bubble into the lime water, you get a white precipitate. So this one must be lime water. So this one must be lime water. And then I told you already, the chemical name for lime water is actually calcium hydroxide. This is our calcium hydroxide, meaning that this one must be calcium oxide. Calcium oxide dissolve in water, you get calcium hydroxide. And then this one, calcium hydroxide, okay, when you bubble the carbon dioxide into the lime water, what do you get? You get calcium carbonate, which is the white precipitate. This is the white PPT, and then plus water. So this chemical equation is very important. You bubble carbon dioxide into lime water, you get calcium carbonate, which is the white precipitate, plus water. Alright? So this one is actually your calcium carbonate. Anyway, you can choose from here. Calcium carbonate, carbon dioxide, calcium oxide. And this one is calcium carbonate. So the answer is A. Alright, make sure you have written all these things down, and this chemical equation is very important. And remember that thermal decomposition of metal carbonate. Now, something to take note of is not all the metal carbonate can be decomposed by heat. Okay, for example, you have this thing, sodium carbonate, as well as potassium carbonate. This one will not decompose. You heat until next year also, it will not decompose, because potassium and sodium are very reactive. So they form a very strong bonds in this sodium carbonate as well as potassium carbonate. So this one will not decompose. Will not decompose by heat. Okay. Number 7, the following apparatus was used to separate two mixable liquids. So this one is actually fractional distillation. Fractional distillation. How does a fractional distillation work? It is to separate, so this is chapter 3, separate two mixable, okay, remember the spelling of mixable, two mixable liquids with different boiling points. That is basically what fractional distillation can do. Now, how about separate mixable liquids? The two liquids can be, how about separate immixable liquids? How about separate immixable? The opposite of mixable is immixable. That means the two liquids cannot mix together. Immixable liquid. This one, you use what method? You use, start with S, separating funnel. Separating funnel, chapter 3. Go and take a look at it. How does separating funnel work? Alright, so this is a fractional distillation. Now, so fractional distillation, this one is liquid S and liquid T. It's quite difficult to visualize these two. Just visualize that you separate water and ethanol. For example, you want to separate water, two mixable liquid, water and ethanol. And water, the boiling point is 100 degrees Celsius, and the ethanol, the boiling point is 78 degrees Celsius. So what happens is, you heat until, let's say, you heat at 30 degrees Celsius, room temperature, right? So at 30 degrees Celsius, 40 degrees Celsius, 50 degrees Celsius, as long as it is below 78 degrees Celsius, what happens is, when you heat, the water and ethanol vapor will rise and condense at the glass beads in the fractionating column and drop back into the flask. So all the vapor will just rise, condense at the glass beads and drop back until when it reaches 78 degrees Celsius. So before 78 degrees Celsius, no distillate will be collected here. At 78 degrees Celsius, the ethanol vapor will be able to pass through the glass beads, go into the condenser, get condensed here, and be collected as distillate. So which means that as you heat, no distillate will be collected. So this is the volume of distillate, right? No distillate will be collected until it hits 78 degrees Celsius. Okay? Until it hits 78 degrees Celsius. That is when the distillate will be collected. Alright? Then after that, after 78 degrees Celsius, in between 78 and 100 degrees Celsius, the volume of the distillate will stay constant. See, this one is not rising, so it will stay constant until when it is 100 degrees Celsius. That is when the water vapor will be able to pass through the glass beads and get condensed at the condenser and get collected as distillate here. Yeah, that's why the temperature, the volume of the distillate will rise here. Okay, so remember, the y-axis is the volume, and then the x-axis is the temperature. So 78, 100, whereby the volume of the distillate will rise, will increase at these two temperature. Alright, let's look at number 8. Deuterium. Now, deuterium is an isotope of hydrogen and has a symbol. Now, what is the definition of our isotope? Isotope is the, this one you got to remember, atoms of the same element having the same number of proton but different number of neutron, not electron, of neutron. Atoms of the same element with the same number of proton but different number of neutron. Which means that isotope is actually the same as the element. It's basically the same element. So if we say isotope of hydrogen, well, the chemical symbol is hydrogen. Okay, it's actually the same as hydrogen. Hydrogen is H, right? Which means that this CD4, the D is the deuterium, right? It's the same thing as CH4. CD4 is the same thing as CH4. It's the same element. Which means that H2O, same. Which means that NH4Cl, same. Which means that ZnOH2, same. When you write like this, then it will be clearer. Which of the following cannot be a compound formed by deuterium? Which means that cannot be a compound formed by hydrogen, because deuterium and hydrogen are the same element. So which one? This one is wrong. Zinc hydroxide. Zinc hydroxide, it should be ZnOH2. It should be like that. This one is methane, water, ammonium chloride. So this one is wrong. D. Number 9, the nuclear number and proton number of an atom. What is nuclear number? Nuclear number is the mass number, which is the number of proton plus the number of neutron. Okay, so nuclear number of proton and neutron. How about proton number? Proton number is the number of proton. So if you nuclear number minus proton number, what do you get? You get the number of neutron. So this one, X for atom X, what is the number of neutron? 39 minus 19, which is 20. How about Y? What is the number of neutron? 40 minus 18, which is 22. Now, which of the following is correct? An atom. Now, when you say atom, atom means what? Atom means the number of proton equals to the number of electron. Has fewer electron, cannot be. The word atom means number of proton is the same as the number of electron. Cannot be fewer electrons. How about for B? An atom of X has fewer neutron, 20. Fewer neutron than an atom of Y, 20 fewer than 22. So it's correct. B. Which of the following is a pure compound? Pure compound, boron. Boron is an element, can be found in the periodic table. Diamond, the element in the diamond is actually carbon. It's in the periodic table, it's an element. Dilute hydrochloric acid. Now, dilute hydrochloric acid is actually a mixture of water and hydrogen chloride. So it's not a pure compound. Sulfur trioxide. Sulfur tri means 3. SO3. Yes, this one is a pure compound. D. Number 11. Which substance contains both ionic and covalent bonds? Ionic covalent, Hi. Non-metal, covalent. No? Potassium carbonate. Potassium carbonate is potassium K plus carbonate. Potassium carbonate, right? So this is ionic because of the ions. Because potassium carbonate consists of potassium ion and carbonate ion. Okay, so ionic. How about within carbonate ion? within this carbonate ion, it is actually the bond between carbon and oxygen. Non-metal, 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 that's covalent. So this potassium carbonate has both ionic and within, so the ionic is in between K plus and CO3 2 minus, and then it also has covalent bonds. It is in between carbon and oxygen. Alright? So the answer is B. If you look at water, water is H2O, non-metal, non-metal, covalent. Zinc is a metallic bond, don't have ionic or covalent. Okay, number 12. The structure of hexagonal boron nitride is similar to that of graphite. Okay, this is very similar to graphite. Graphite, the difference between graphite and boron nitride is in graphite, all these atoms are carbon. What properties would boron nitride have? Can be used as a lubricant? Yes, because of the weak van der Waals forces holding the layers of carbon atoms. Alright, so this one, yes, it is an electrical conductor. Now, is graphite an electrical conductor? Graphite, it is an electrical conductor because each carbon atom is bonded to the other 3 carbon atoms, so there will always be one valence electron which is not bonded, which is free to move about. Now, when you look at this case of boron is it's 2,5. The proton number is 5, so its electronic configuration is 2,3. Nitrogen is 2,5. So if you look at boron, 2,3, right? 2,3. Boron is this one, 2,3. So it share 3 pairs of electrons with the nitrogen atoms. Yeah, so all the valence electrons are used in the bonding. So there is no delocalized electron or no free electron that can move about to carry the charges. So that's why it is not an electrical conductor. Alright, it has high melting point, yes, because same structure as graphite. So graphite also has high melting point. So it is correct, 1 and 3. So the answer is B. Okay, let's look at number 13. Number 13, bismuth 3 oxide has the formula Bi2O3. Okay, so basically it consists of Bi 3 plus O2 minus. Now sodium phosphate, this one consists of Na plus PO4 3 minus. Okay, you just have to work backward, you get the formula for phosphate. Anyway, you are supposed to remember the formula of this polyatomic ion, phosphate ion. So bismuth 3 is Bi 3 plus lah. This 3 means 3 plus. So what is the formula of bismuth 3 phosphate? So it's Bi 3 plus PO4 3 minus. See, 3 plus 3 minus just cancel off exactly. So which means that the formula is Bi PO4. You can also cross multiply. I mean, if you would like the cross multiply method so much, you can also cross multiply, so it become like that. Then you simplify 3 and 3 divided by 3 divided by 3, so become BiPO4. It's the same thing. It is the same thing. So the answer is A. Okay, number 14. Acetylene C2H2 is used in welding and it was produced by the reaction shown below. What is X? Now, so this one, you don't know what is X, right? All you need to do is to add up all the atoms of all the elements on both sides. Yeah, so in this case, 1 calcium, 2 carbon. This one is 4 hydrogen, 2 oxygen, correct? Okay, this one is the left hand side. Right hand side, 2 carbon, 2 hydrogen. So what is remaining? See, 2 hydrogen, 4 hydrogen. So what is remaining? What is remaining would be the X. So the X would have 2 hydrogen, definitely. Okay, 2 carbon, 2 carbon, cross out, 2 hydrogen. So this one 4 hydrogen. 2 hydrogen, 4 hydrogen. So left 2 hydrogen here. So this one is 2 oxygen. 1 calcium. So this X would have 1 calcium, 2 oxygen, 2 hydrogen. So which one? Which one of this? 1 calcium, 2 oxygen, 2 hydrogen. So the answer is D. Easy, right? It is easy. Okay, the structural formula of a molecule is shown in the diagram. So which of the following shows the correct empirical molecular formula of this molecule? So empirical formula, just count the number of phosphorus atoms, 1, 2, 3, 4, and then count the number of oxygen, which is 8. So this would be the molecular formula. Molecular formula is the actual formula of the substance, P4O8, and the empirical formula is the simplest formula, which is PO2. Number 16, the relative atomic mass of magnesium is 24. This means that what is the definition for relative atomic mass? What is the definition? So definition of AR, what is it? It is basically the average mass of an atom, okay, compared to the average mass of an atom compared to 1/12 the mass of a carbon 12 atom. Now over here, average mass of an atom compared to, you can also say average mass of an atom, or the number of times, or average mass of an atom, or the number of times that the mass of an atom is heavier to 1/12 of the mass of a carbon 12 atom. Okay, so instead of saying compared to, you can say heavier than. How many times it is heavier than? So the answer is D. Average mass of a magnesium atom is 24 times heavier than 1/12 of the mass of a carbon 12 atom. Okay, because your magnesium, the AR, is actually 24. Okay, it is not 2, it's 24. Yeah. So compared to 1/12 of the mass of a carbon 12 atom, the AR for magnesium is 24. So you must have 24 here. Not all atoms, is the average mass of an atom, of an element. Okay, 16. Then let's look at 17. Okay, 17. 1 mole of hydrated magnesium sulfate. This one is dissolved in water. How many moles of ions does the solution contain? 1 molar is this one. So this one you can split. You can split. Magnesium sulfate consists of what ion? Magnesium ion, Mg2 plus, and sulfate ion. Don't tell me Mg2 plus and then what? S2 minus and then O2 minus. Remember S and O, this sulfate, SO4, is polyatomic ion. You cannot split them up. So SO4 has to be always together. Same thing with all these NO3 minus, nitrate ion, carbonate ion, phosphate ion. All these you cannot split them one. You cannot split them up because polyatomic ion, meaning that they are destined to be together. You cannot split them up. So 1 mole of this magnesium sulfate, it consists of 1 mole, 1 mole. So altogether 2 mole. So 2 mole of ions. Okay, number 18. In the reaction between 800 tons of iron 3 oxide and excess carbon. So this one is excess. Now remember, excess is useless. No need to look at it. 800 tons. 800 tons. 1 ton is how many kilogram? 1,000. But in this case, you don't need to do that. Don't need to convert. Excess carbon in the blast furnace, 300 tons. So always remember, write down the information given above the chemical formula. What is the percentage yield of iron? So this one, sorry. This one is 300 ton. So what is the percentage yield? So same thing. Look at the mole ratio. Okay. So what is the mole ratio? Mole ratio of what? Mole ratio of this and this. So mole ratio of Fe2O3 and Fe. Okay, so mole ratio is 2 mole to 4 mole. 2 mole, 4 mole. Now because because the question give the mass tons, so it's very difficult to change this mass to the number of mole. That is why instead of changing mass to the mole, which is a very big number, I change the mole to the mass. That means I look at the mass ratio. So 2 mole of this, what would be the mass? Okay, 2 mole of this, what would be the mass? So that means the number of mole times the MR, times the MR of this, which is 56 times 2 plus 3 times 16, which if you work out, it should be 320 gram. How about this one? This one would be 4 times 56, alright? And this would be 224 gram. See, the mass ratio of Fe2O3 and Fe is 320 gram, 224 gram. Okay, this is the mass ratio. Now, I have 800 tons here. This one, I don't know what is it. See, gram, gram, ton, ton. No need to change the ton to gram. No need. Just remember, this and this must be the same unit. This and this must be the same unit. Which means that at the end of it, the X that I find out would be in tons. So this one must be in tons. Alright? So how do you solve for X? So X equals to 800 times 224 divided by 320, and that would be equals to 560. So basically, what does it mean here? 560 tons. Basically, what it means is that, okay, if I use 800 tons of Fe2O3, I should get 560 tons of Fe. I should. But what am I getting now? I'm getting only 300 tons. So the percent yield would be 300 560 times 100. Because 560 tons is what I should get. But the question told me that I only get 300 tons. Okay? So the answer would be, it's about, I think it is about like this, which is, the closest answer is 54%. So the answer is D. Alright? So make sure you really understand this working. Again, copy this down. Okay, number 19. One of the minerals that makes up the gemstone is jadeite.